So what we're going to be asked to do is first we're going to solve for the inequality. It's kind of like solving equations, but with an added extra little rule thrown in. And then once we've got the inequality solved, then we have to match the picture down here. All right, so here, think of it like an equality, an equal sign here. We want to get x all by itself. So what are we going to do? Well, we're going to add 8 to both sides. So the minus 8 plus 8, that's 0. So now you end up with x is greater than 13. And so that's your inequality. So that's what you're going to write right here. You're going to put x is greater than 13. And now we need to figure out, well, which one of these pictures matches. And because it's a greater than, not greater than or equal, we know it's got to be a soft stop. So it's got to be one of these, because these are the soft stops. These are the hard stops. So we know it cannot be this one. We know it cannot be this one. And because x is greater than 13, we know it's got to be this one right here. So the answer is C. All right, we're going to do that again, different problem. So we've got, let's see, we've got 3 minus y is less than or equal to 9. So the first thing we've got to do is solve for this inequality. Now, remember, this 3 is a positive 3. And so if I want to get y all by itself, first thing I have to do is subtract both sides by 3, because plus 3 minus 3, that's 0. So we end up with negative y is less than or equal to 6. All right, because 9 minus 3 is 6. Now, here's a negative. Now, I want you to think of this as a negative 1, right? Because whenever you don't have a number in front of the letter, it's a 1. So I'm going to divide both sides by negative 1. And so the left side, negative 1 divided by negative 1, that's 1. It's a positive 1. So the left side gives us y. The right side is negative 6, because 6 divided by negative 1 is negative 6. Now, anytime you divide by a negative, like we did just here, or multiply by a negative, you have to reverse your symbol. So this less than or equal symbol suddenly becomes a greater than or equal symbol. So the only time this suddenly changes is when you divide or multiply by a negative. So here is our inequality. Y is greater than or equal to negative 6. So we know it's or equal, so it's got to be a hard stop. So it can, let's see, it can't be this one, because that's a soft stop, and it can't be this one, because it's a soft stop. So y is greater than or equal to negative 6. That's going to be this one right here, greater than or equal to negative 6. And that wraps up that problem. The other thing I want to point out, just like the equations that we were solving, I'm trying to line up everything by that symbol just to keep everything nice and neat. So we've got 15 is less than 5 plus z. And so we're going to solve for that inequality, and we want to get z all by itself. Well, this 5, we need to remember, is a positive 5. So to get rid of it, we're going to subtract 5 by both sides. So positive 5 minus 5, that's 0. So the right side is just z. And then we have that less than symbol. And then 15 minus 5 is 10. So our answer is 10 is less than z. Now, another way to think of that, which number is bigger, z or 10? Well, z is bigger than 10. So if you wanted to, you could have written it like this. Z is bigger than 10, greater than 10. Again, it's a soft stop because there's no or equal. So when we are trying to figure out, okay, which equation or which number line matches z is greater than negative 10, we know it's got to be a soft stop, so it cannot be this one, and it can't be this one, because those are hard stops. So the only one that says z is greater than 10 is this one right there. And again, the more of the same is just that the problems are getting a little bit more complicated each step of the way. So we've got 2x plus 6 is less than or equal to x plus 5. So we've got variables on the left and variables on the right. We've got constants on the left and constants on the right. So what I want to do is I want to manipulate things so that all the variables are on one side. I prefer the left, I don't know why. And then all the constants are on the right. So the first thing I'm going to do is subtract an x from both sides. So this becomes 0. So we end up with 1x plus 6 is less than or equal to 5. Now I'm going to subtract 6 from both sides. So I end up with, and this is a 0. So I end up with 1x is less than or equal to negative 1. And so really that's the same thing as just saying x is less than or equal to negative 1. So we know it's going to be a hard stop because it says less than or equal. And we know x has to be less than negative 1. So when we look at that, hard stop and less than negative 1, that's this one right here. Hard stop, less than negative 1. Now we're going to solve, but this time we're dealing with multiplication. So we have to be careful with that rule, which is if you multiply or divide by a negative, that means you need to reverse the symbol. But in this case, we don't have anything to worry about because everything is positive. We're going to divide both sides by 4, so that becomes 1. So we end up with x is greater than 8. And because this is a soft stop, we're going to look for the soft stop at 8, and x is greater than 8. So it's right here, this guy. There's our soft stop at 8, and it's greater. And that wraps up a pretty simple one. So we are going to solve this inequality and then graph it. And so what we've got down here is negative 1/2 t. All right, so now if I want to, this is actually kind of a nice idea. You can take that negative and attach it to the numerator. So you get negative 1 over 2 t is greater than or equal to 8. And now what I'm going to do is I'm going to multiply both sides by 2 over negative 1. 2 over negative 1. And when I do that, this is a negative times a negative, so it ends up being just a plain old positive 1. So that becomes positive 1. So we end up with t is greater than, wait. It's not going to be is greater than. Because, did you pay attention? I multiplied by a negative, which means this symbol has to reverse. It was a greater than or equal. Now it becomes a less than or equal. And the right side becomes 16 over negative 1. And that's really t is less than or equal to negative 16. So there is our answer. And boy, that's the trick right there. When you multiply by or divide by a negative, this inequality symbol has to reverse. So we can see it's a hard stop at 16 and it's less than. So it's a hard stop at negative 16 and less than. So where is that? Hard stop at negative 16, there it is, and less than. It's right there. All right, now it's just a little bit easier. Now all we have to do is solve it and then write it down. And so we've got 6x is greater than or equal to negative 24. We're going to divide both sides by 6. 6 divided by 6 is 1, so you get x. And then negative 24 divided by 6 is negative 4. And the question is, does our inequality switch? And the answer is nope, it stays the same. Because we didn't divide by a negative, we divided by a positive. Yes, I know negative 24 is negative, but it's what we're dividing by that matters. And since it's not a negative, it's a positive, that means the symbol stays the same. So our answer, x is greater than or equal to negative 4. So you are going to write this in this box right there. And we've got 5x minus 1 is less than 39. And so what are we going to do? Well, the first thing we're going to do is we're going to add 1 to both sides. So negative 1 plus 1 is 0. So the left side is 5x. 39 plus 1 is 40. And does the symbol stay the same or does it change? Well, it stays the same because the only time it changes is when you multiply or divide by a negative. And so we now have to divide both sides by 5. 5 divided by 5 is 1. So you end up with x is less than 8. And the symbol doesn't change. This symbol doesn't change because we didn't divide by a positive. We didn't divide by a negative. So x is less than 8 is our inequality. And that is what you would type in right there. All right, we're going to solve this inequality, and we got to get x all by itself. So the first thing I want you to know is that 5 is really a positive 5. So we need to subtract both sides by 5. So this becomes 0. And so we end up with, and what I'm going to do is, well, I'm going to put negative, and then it's going to be 7/8 x is greater than or equal to 1. Okay. Now the thing is, when you have this negative here, you are allowed to take it, and apply it. So I'm going to erase it. And I'm going to erase it there. And then I'm going to apply it to the numerator. So basically it was down here and I just moved it up here. And so now I've got negative 7/8 x is greater than or equal to 1. So what am I going to do? I'm going to multiply both sides by negative 8/7. I'm going to multiply both sides by negative 8/7. And so what do I get on the left? Well, the left is going to be negative 8 times negative 7 is positive 56. 7 times 8 is positive 56. So I'm going to end up with 56 over 56. So this whole chunk right here is equal to 1 whole. So I end up with just x on the left. The right side is going to be negative 8/7 because negative 8/7 times 1, anything times 1 is itself. Now because I multiplied by a negative, this inequality has to switch. It reverses. So it goes from greater than or equal to less than or equal, and that is the answer that we're going to put in our box right up there. All right, we're going to solve this ugly looking inequality, and we are going to, let's see, bring this up right there, and there is our inequality that we are going to solve. And first thing I notice is I've got a variable on the left and a variable on the right. I've got a constant on the left, constant on the right. And so what I need to do is I need to collect all the variables on one side, all the constants on the other. I prefer to have my variables on the left. So first thing I'm going to do is I'm going to add 8.6x to both sides, and that's a positive, and that becomes 0 because minus 8.6 plus 8.6x equals 0, and so the inequality stays the same because it only changes when you're multiplying or dividing by a negative. So I get 60.5 on the right side. And then over here, I get 8, 9, 10, 11, 12. So that's 12.1x plus 24.2. All right. And then I'm going to subtract 24, except I want to do it in red, 24.2 from both sides. And this right here, plus 24.2 minus 24.2, that equals 0. So we end up with, on the left, 12.1x is greater than or equal to, and that's going to be a 3.20. Okay, so it's going to be a 36.3. 36.3. And then I'm going to divide both sides by 12.1, because 12.1 divided by 12.1 is 1. So you end up with x, and then 36.3 divided by, 36.3 divided by 12.1. I don't know what that is, so I'm going to grab my calculator and I'm going to type in 36.3 divided by 12.1, and I get 3. Now the question is, does our inequality change or does it stay the same? Well, because the number I divided by is positive, it stays the same. So our answer is x is greater than 3. And that is our work. I want you to, again, whoa, go away. And I want you to notice again, kind of I'm being a stickler for this, but it's important. All of my inequalities are lining up nice and neat. And that wraps up this video.